So here are some of the types of problems you will see in section 4.1. This first example says find the critical numbers of the function. And there's a function listed there. So the thing we have to remember is that critical numbers, these are going to be a really important concept. Critical numbers occur where f prime of x equals 0 or where f prime of x does not exist. So whenever we are asked to find a critical number, we need to figure out where the derivative is 0 or where the derivative does not exist. So going back over to this problem, we could say, well, f prime of x equals 3x squared plus 2x minus 1. We want to first of all look at that, and as far as the derivative doesn't exist, it exists everywhere. That's a polynomial. So that derivative will exist everywhere. There's no values you could plug in for x to make this derivative not exist. So as far as this goes, we don't have to worry about it, which means we just have to worry about this. We need to figure out where the derivative is 0. And that just means we need to solve this second degree equation. And since it's a second degree equation, we know we can solve it for sure, right? Because we could definitely use the quadratic formula and see if there are solutions to this, real number solutions. But in this particular case, this one will factor, which makes it a little easier. We have factors like this. And as we know from algebra class, if this times this is 0, it means that at least one of these has to be 0. It could be either one. So it could be that 3x minus 1 equals 0, which means that 3x equals 1, or x equals 1/3, or it could be that x plus 1 equals 0, or x equals -1. So there are two critical numbers. These are the two critical numbers, x equals 1/3 and x equals -1. So let's try one that's a little bit more work. So let's say we've got problem number 2, which says g of t equals 5t to the 2/3 plus t to the 5/3. So again, we're looking for critical numbers, which means we need to find the derivative and see where the derivative doesn't exist or see where the derivative is 0. So g prime of t equals, well, I've got the power rule here, right? So you get 10/3 t to the 2/3 minus 3/3, which is t to the -1/3, plus power rule again, 5/3 t to the 5/3 minus 3/3, which is t to the 2/3. So looking at this, I'm just going to rewrite this one a little bit. If I were to write this as 10 over 3t to the 1/3 plus 5/3 t to the 2/3, well, when I write it like this, it makes it easier to see that this derivative is going to have a problem if t is 0, because we'll get division by 0. So because of that, just looking at this, we can see that g prime of 0 does not exist. So t equals 0 is a critical number. So we've got one critical number so far, t equals 0. So we also have to set this equal to 0 to see if we've got more critical numbers. So if I take this g prime of t, and it is 10 over 3t to the 1/3, I'm going to write this differently. And you'll see why in a second here. Because once I set it equal to 0, when you have these fractions like this, rational expressions, so to solve this, I'm going to subtract this from each side, and then we'll have a proportion. And that's going to make life easier for us. So what this means is that 10 over 3t to the 1/3 equals negative 5t to the 2/3 over 3. And then we can take the cross products because we've got a fraction equal to a fraction, we've got a proportion. So if we take the cross products, we will get, if I multiply this times this, set that equal to this times this, we're looking at this way, and when I multiply here, we're going to get negative 15t to the 1/3 plus 2/3, right? So that's just going to be negative 15t to the 3/3, or negative 15t equals 30, which then of course means if I divide each side by negative 15, then we get t equals negative 2, and this is also a critical number. So in this case, there are two critical numbers. So in homework, you'll have a few of them where they're going to ask you to find the critical numbers. And then the reason you do that really is to be able to solve these absolute maximum and minimum value problems. So let's take a look at another typical problem. One like this, where we'll see example, find the absolute min and absolute max values of some function f on the given interval. Okay, so here is what we want to do, and we'll look at a couple examples here. We'll look at an easier one first. So let's look at maybe, we'll try this one. Look at example 1. It says f of x equals x to the 4th minus 2x squared plus 3, and they give us this interval from negative 2 to 3. So if you remember what we're looking for here, the absolute max, absolute min and absolute max, absolute, not local, the absolute min and the absolute max, the greatest and the smallest numbers of this function on this interval. So what we have to do, if you remember the notes from the first video, what we need to do is we need to look at the critical numbers of this function, which you'll find all the peaks and valleys of the function. Peaks and valleys are where the absolute maximum may occur. And then we also have to consider these endpoints. And if we look at the critical values here and the endpoints here, then we'll find every possible place there could be an absolute max and an absolute min. So first we need to find these critical numbers. So we need to find this, take this derivative. We get 4x cubed minus 4x. And we can see that this derivative is going to exist for any value of x. So the derivative exists everywhere. So the only thing we have to look for is where this derivative is 0. So to solve this, we could factor out 4x. X squared minus 1 equals 0. And we can actually factor x squared minus 1, right? This is the difference of squares. Or even if you set this equal to 0 and then solve that, you're going to get two answers, 1 and negative 1. So however you want to do that is fine. So if you do factor it, you would get x minus 1, x plus 1 equals 0. Because this is a difference of perfect squares. In algebra class, you would have learned that it factors this way. And now we've got something times something times something is 0. The only way that can happen, we multiply three things together and get exactly 0, is if any one of these is 0. And it could be any one of them. So it could be that for x equals 0. Could be that x minus 1 equals 0, or it could be that x plus 1 equals 0. So in this case, we would get x equals 0. Here we get x equals 1. Here we get x equals -1. And these three numbers, these are our critical numbers. So what we're going to need to do for sure is check each one of these numbers into the original function, but then we also need to check the endpoints. So basically what we need to do at this point is do this. We look at f of 0, f of 1, f of -1. We also need to consider the endpoints, f of -2 and f of 3. Now remember, when you're looking at these, this goes into the function f, not into the derivative. It's a really easy mistake to make, but we're wondering about the max and min values of the original function. So we need to plug in 0, 1, -1, -2, and 3 into the original function. And if you do that, you'll find out that f of 0 is equal to 3, f of 1 is equal to 2, f of -1 is also equal to 2, f of -2 is 11, and f of 3 is 66. And then our absolute min and absolute max will be considered between these numbers here, be determined by these numbers. So we can see that right here. We've got our absolute min. I'm going to use a different color. Here is our absolute min, right? Our absolute minimum value of this function is 2. And our absolute maximum value of this function is 66. Notice I did not say that the absolute maximum is 3. It's not 3. It's 66, the y value, right? You could say the absolute maximum is this point 3 comma 66, but we need the 66. Same thing here. We don't have to say the absolute minimum is 2 and 2. It's just 2. And it occurs when x is 1 and also when x is -1. Okay, now the last one we look at is one because I knew you guys would be very sad if we didn't have any trig. So this one's a little trickier, but it'll be a good one for us because we can practice some trigonometry. So let's look at this example. And this function is f of x equals cosine of x over 2 plus sine of x. And it's on the interval x is between 0 and 2 pi. So it's on this interval. And let's see, this is a comma. Looks a little strange though. Okay. So same thing as before, we need to find the critical numbers, and then we need to evaluate the function at the critical numbers, and also we need to evaluate the function at the two endpoints, 0 and 2 pi. So first thing to do is go ahead and find f prime of x, and in this case we're going to have to use the quotient rule. So f prime of x equals low d high, right? Low d high minus high d low, derivative of low, all over the square of the bottom we go. So that's an x there. This is equal to 2 plus sine of x times negative sine of x, right? The derivative of cosine, minus cosine of x times the derivative of 2 plus sine of x. The derivative of 2 is 0. Derivative of sine of x is cosine of x. All over 2 plus sine of x squared. So what I'm going to do is distribute this through just to see what happens. So we will get -2 sine of x minus sine squared of x minus cosine squared of x all over 2 plus sine of x squared. And then, let's see, we can do something here. I know some of you see this. If we pull out a negative, we're going to get sine squared x plus cosine squared x over 2 plus sine of x squared. And I'm sure you recognize this Pythagorean identity as being 1. So this is equal to -2 sine of x minus 1 all over 2 plus sine of x squared. So here's our derivative. So if you think about the bottom here, is there anywhere where this derivative does not exist? Well, sine of x we know is locked in between -1 and +1. The only way we could get find a spot where this derivative doesn't exist is if this denominator were equal to 0. And the only way the denominator could be 0 is if sine of x were equal to -2, which it can't. It's stuck between -1 and 1. So there would be no worry about division by 0 in the denominator. So this derivative exists everywhere. And we just have to worry about where the function equals 0. So a couple ways you can think about this. For a rational expression or fraction to be equal to 0, that means the numerator must be equal to 0. It really doesn't have anything to do with the denominator. The only way this whole thing can be 0 is if the numerator is 0. So to solve this, you could just immediately say, well, I'm just going to set the numerator equal to 0. Or you could even think of it as, well, I could multiply both sides of the equation by this denominator, and once you do that, this will still be 0 over here, but this would disappear and leave us with the numerator. So whichever argument you want to use, we'll get -2 sine of x minus 1 equals 0. We just have to solve this. So if I add 1 to each side, I get -2 sine of x equals 1. Divide by -2, and we will get sine of x equals -1/2. And then we have to solve this equation. So to solve this one, we need to think about, where is sine a negative number? Where is sine negative? So think about quadrants where sine is negative. Sine is negative wherever y is negative. So y is going to be negative in the third and fourth quadrant. So we've got an angle here and here. And you could also think of it like this if you just think of the sine graph. There's pi and 2 pi, and we know that sine goes like this. And we know that this is 1 and -1. Well, if you think about where is sine -1/2? Well, here's -1/2. And then you can split up these quadrants this way. So this is between 0 and pi halves. That's the first quadrant. Here's the second quadrant between pi halves and pi. Then pi and 3 pi halves. That's the third quadrant right here, which we can see. And then the fourth quadrant is between 3 pi over 2 and 2 pi. And we can see it crosses twice in these quadrants. So sine is negative here and here. Then we think, well, sine is equal to -1/2. So if this is the angle, sine is opposite over hypotenuse. And then that's using Pythagorean theorem, this would be the square root of 3. And you could think of it as, well, it's kind of like a negative square root of 3 and a -1. In this third quadrant, x and y are both negative. And over here, if I'm on this angle and sine is Opposite over hypotenuse, it's 1 over 2, and this is the square root of 3. And over here, of course, at this point here, the y value will be negative, so it'd be like a negative 1. So to solve this one, to figure out which value of x, what angle x causes sine of that angle to be negative 1/2, we could think of, well, if you start from here and you go over to this, well, this angle is going to be a 30-degree angle where it has 1 and 2, right, or pi over 6. So if we start here, which are standard, standard angle here, and we come over here, so this is going to be, the video just did something weird, so sorry about the interruption here. So we're coming over here, so this is going to be pi halves, right? Or 6 pi over 6 plus another pi over 6 makes 7 pi over 6. So that means that our answer here, x equals 7 pi over 6. But then there's another angle also. We also, if we start here and go all the way over here, well, this angle is pi over 6 away from going all the way around. All the way around would be 2 pi or 12 pi over 6. So this is going to be 11 pi over 6. So x equals 7 pi over 6 and also 11 pi over 6. Remember, originally it said that x is between 0 and 2 pi. So what that means is these are critical numbers. These are critical numbers. So what we have to do is evaluate this function at the critical numbers and also at the endpoints. So we need to look at this. We need to look at f of 7 pi over 6, f of 11 pi over 6, f of 0, and also f of 2 pi. We need to check all of these points and then figure out which one of these is the largest and which one is the smallest. So if you remember our original function, I'm going to write down this original function here. F of x equals cosine of x over 2 plus sine of x. So we need to figure these out. So when we're figuring out this first one, 7 pi over 6, I'm going to refer back to this picture here. So the 7 pi over 6 angle is this one here. So when you look at cosine of 7 pi over 6, it's basically cosine of this angle. In trig class, you may have called this a reference triangle. So cosine of this angle here, cosine being adjacent over hypotenuse, the cosine of that is going to be negative square root of 3 over 2. So in this case, it's going to be negative square root of 3 over 2 over, and now we look for the 2 plus sine of x. So it's going to be 2 plus, so you get 2 plus, and then we figure out sine of x. Well, sine of 7 pi over 6, sine of this, sine is going to be opposite over hypotenuse, which is negative 1/2. So this is going to be 2 plus negative 1/2, which is going to be negative square root of 3 over 2 divided by 3 over 2. Or, in other words, if we, instead of, we don't want to have this complex fraction, and a fraction. So instead of negative 3 over 2 divided by 3 over 2, we could do negative 3 over 2 times the reciprocal of this, which would be like multiplying this by 2/3, which if we were to do that, we would get things, the 2's would cancel and we get negative square root of 3 over 3. So that's what we get for the function at 7 pi over 6. Now, if we do the same thing at 11 pi over 6, we get something very similar. 11 pi over 6 is over here. So cosine of 11 pi over 6, cosine of this is going to be positive square root of 3 over 2. And then when we when we put the numerator in here, 2 plus sine of 7 pi over 6, sine of this is going to again be negative 1/2. So when we write this one in, we're going to get positive square root of 3 over 2. And then the bottom, we're going to get, again, 2 plus negative 1/2. We still get square root of 3 over 2 divided by 3/2, or in this case, we'll get the square root of 3 over 3 positive. So those were probably the most work. So f of 0 will be a little easier. F of 0, cosine of 0 is 1. Sine of 0 is 0, so it's going to be 1 over 2. So we plug in the 0, and we will get 1/2. And then when you plug in the 2 pi, we'll get something similar. Think of the cosine graph. We can make the cosine graph real quick here to remind ourselves that's pi and that's 2 pi. And then cosine goes like this, right? So if we have the cosine of 2 pi, there's pi, 2 pi, cosine of 2 pi is 1, so we get a 1 here. And then sine of 2 pi is going to be 0, so we get 1 over 2. So this one we get 1 over 2. Now let's be consistent here. We will get 1 over 2. So looking at these numbers, we can see the minimum is definitely going to be this. This is the negative. So this is the absolute minimum. The absolute minimum value this function takes on in the interval 0 to 2 pi. And then this one, if you punch this in your calculator, you'll see this is approximately equal to 0.58, which is bigger than 1/2, so that this is going to be our absolute maximum. So hopefully that will get you guys a good start on the homework. So give 4.1 homework a chance, give it a shot, and remember I'm here for office hours. I can also answer email questions, so even though we're not in class and I can't nag you individually like I normally can, make sure you do your homework. It's super important. And let me know if you have any questions.